Good morning, dear students. Welcome back to Maths class. Students, in today's session, we will discuss about the components of a vector and we will do some important remarks with exercise 12.3 that is completely related to the direction ratios and cosines with position vectors and by using the previous results of exercise first and second. So let's start. Components of a vector in three dimensions. Students, here we have three dimension space x-axis, y-axis and z-axis where I cap, j cap and k cap are the unit vector along the axis, coordinate axis. So here we have 2 points. First point is P and second point is Q. Its position vector is x1, y1, z1 and position vector of Q is x2, y2, z2. We need to calculate the components of vector in three dimension. So students, for that the quantities x2 minus x1, y2 minus y1 and z2 minus z1 are called the scalar components of vectors pq. Okay, along the x-axis, y-axis and z-axis respectively. x2 minus x1 I cap, y2 minus y1 j cap and z2 minus z1 k cap are called the component vectors of the vector pq. So in this way, if we calculate pq vector as position vector of q minus position vector of p, then we get x2 minus x1, y2 minus y1, z2 minus z1 are called the scalar components and x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap must be the component vectors of the vector pq. So in this way, if we write I cap, j cap, k cap along with the scalar components, then we call this as component vectors of the vector pq. Next is the magnitude of a vector. Students, here we have magnitude of a vector. Suppose the magnitude of a vector pq where coordinates of p and q are x1, y1, z1 and x2, y2, z2 respectively is given by magnitude of pq vector is equals to square of the components by adding and taking the under root. In particular, for P origin and Q x y z, we have R vector is equals to xi plus yj plus zk. We calculate this as x minus 0 I cap plus y minus 0 j cap plus z minus 0 k cap. So here magnitude of PQ vector is equals to under root x square plus y square plus z square, where R vector is the position vector of the point Q and xi, yj, zk are called the vector components of R vector. Here we have some important remarks. First is the vector joining 2 points. If we have 2 points P and Q, then the vector joining P and Q is given by position vector of Q minus position vector of P. So we write here x2 minus x1 I cap plus y2 minus y1 j cap and z2 minus z1 k cap. And magnitude of PQ vector must be equal to square of components by adding, okay, and by taking the under root. Next we have the direction cosines and direction ratios of vector in terms of components. Students, in the previous lecture, I have explained to you about the concept of direction cosine and direction ratio. Now, how we can calculate the direction ratio and cosine. Suppose students, if we have a vector, any vector, then direction ratios of this vector must be a1, a2, a3. That is the scalar components. This is the written work for writing down the direction ratios. That means position vector must be taken in the arrows bracket, then that will be called the direction ratio. Now we need to find the direction cosine. So for that, if we take a unit vector parallel to a vector, then that must be a cap is equals to a vector over magnitude of a vector. By putting the value of a vector and magnitude, we get a cap is equals to a1 over summation of a1 square plus a2 square plus a3 square, and in short we can write as summation a1 square. In the same way, we get the component of j cap and k cap. Then if we write these components in the brackets, arrow brackets, then these are the direction cosines of a vector A. So that is, components of unit vector parallel to vector A are the direction cosines of A vector. In this way, students, direction cosines are directly proportional to the direction ratio. You can observe that numerically both are equal, but there is just one difference of under root summation a1 square plus a2 square plus a3 square. Okay, now let's start the solved examples. Example number 1 is, let a vector is equals to I plus 2j and b vector is equals to 2i plus j is a vector is equals to b. Students, they are asking us, is a vector is equals to b? So are the vectors a and b equal? So let's start. We have a vector is equals to I plus 2j and b vector is equals to 2i plus j, and so here a vector is magnitude is square of component, adding the square of component by taking the root, we get under root 5. In the same way, magnitude of b vector is square of components. In the same way, by adding and taking root, we get root 5. So magnitude of both the vectors are same. The two vectors a and b are not equal since their corresponding components are distinct. Here students, they are asking us, magnitude is equal, but are the two vectors equal? Here components of a vector and b vector are unequal. So here the two vectors are not equal since their corresponding components are distinct. Next question we have example number 2nd. Find the values of x, y and z so that the given vectors are equal. Equal means vectors are equal if their components are corresponding components are equal. So we equate here. In this we get, on comparing, we know that the two vectors are equal if and only if their corresponding components are equal. So by comparing the components of a vector and b vector, we get a1 is equals to b1, a2 is equals to b2 and a3 is equals to b3. So we get here, on comparing, x is equals to 2, y is equals to 2 and z is equals to 1. Next we have question number 3rd. This is very easy. Find the vector PQ in terms of ijk joining the points P and Q. Also we need to find the magnitude as well. So here vector PQ, for that we write here position vector of Q minus position vector of P. So here we get 0 plus 1i, 1 minus 2 j cap, 5 minus 3 k cap. We get I minus j plus 2 k cap, and its magnitude will be, adding these components, square of components by adding and taking root, we get value under root 6. So in this way we have completed question number 3rd. Now students, look at question number 4. This is very easy. Given a, b, c vectors and we need to compute a vector plus 2b vector. Students, this is very simple question. We need to just put value of a vector and b vector, and after that adding the same components we will get here 8 minus 3 we get 5i. In the same way, by adding the j, and in the same way if we have k, then we must add k. So by using the same concept we can solve the second and third part as well. Here we have question number 5. This is very important question. Question number 5. Find a unit vector in the direction of vector. A vector is given. We need to find a unit vector in this direction. So here, unit vector in the direction or along this vector or parallel to the vector. Meaning all the parallel, along, or in the same direction all have same working rule. So unit vector in the direction must be this one. So we need to calculate the magnitude of a vector. Magnitude of a vector is square of components and add an under root. We have under root 14. So by putting the value in the formula of a cap, we get a vector over magnitude of a vector. So we get here answer 2 over under root 14 I, 3 over under root 14 j, 1 over under root 14 k. Next question is find a vector in the direction of vector that has magnitude 7 units. Students, in this question, we need to calculate a vector in the direction of a vector that has magnitude 7. So in this question, we find a vector that is unit vector in the direction of a vector, and that unit vector will be multiplied with 7. In this way, we get 7 units answer. So let's start. First, we will calculate the unit vector of a vector. After that, multiply this unit vector with 7. This is very easy question. You can solve this one. I am sharing you the solution. This is NCERT question. Next question is find a unit vector parallel to the sum of vectors. That is, here it is given that a and b vector. We need to find a unit vector parallel to the sum of vector. That means if we add these two vectors, we get a vector, and we need to find a unit vector that is parallel to c vector. So first, by doing the sum of a and b, we get a r vector, and now we need to calculate the unit vector of r vector. So adding this 2i plus I, we get 3i, and 4j plus 2j, we get 6j, minus 5k plus 3k, we get minus 2k. And its magnitude will be square of 3 plus square of 6 plus square of minus 2. And by taking the under root, we get 7. Now, unit vector parallel to r vector will be r vector over magnitude of r vector. So in this way, this is your required result. Next question is very important. Question number 8. If a vector, b vector are position vectors of the points, find the value of m for which a and b are collinear. Here we have two vectors whose position vectors are given, and here we need to find the value of m for which these points are collinear. Collinear means both the vectors are equal but different only by some constant. So here we can write b vector is equals to t a vector, where t is some scalar. By putting the value and comparing, we get minus 2 is equals to t and m is equals to minus t. So t is minus 2. By putting the value of t, we get m2. In this way, this is your required result. Next question is question number 9. If a vector is position vector whose step is 1 minus 3, find the coordinates of the point B such that AB vector is equals to A vector if A has the coordinate minus 1, 5. Students, here A vector is position vector whose step is given, and we need to find the coordinates of the point B such that AB vector is A vector and A has coordinate given minus 1, 5. So here A is equals to I minus 3j, that is given in the question, and minus 1, 5 are the coordinates of A also. So let xy be the coordinates of B. Position vector of A and B are given. So we need to calculate AB vector first. After that, AB vector is equals to A vector. So for that, we put the value, we get x plus 1i, y minus 5j is equals to I minus 3j. Comparing the coefficients of I and j, we get the values of x and y. On solving this one, we get the coordinates of B. So in this way, we have completed question number 9. Next we have question number 10th. Same question we have done yesterday in the previous video. The three vertices of parallelogram are given. We need to calculate the coordinate of vertex D. In parallelogram, opposite sides are equal and parallel. So here we find AB vector, DC vector. So here position vector of A, position vector of B are given in this statement. Here it is given the coordinates -2, -1, 3, 0. So if we write this coordinate in the form of components, then we write here -2i minus j, and position vector of B must be 3i plus 0j. So in the same way we write here C and D as well. So find AB and DC vector because these two sides are opposite to each other and equal in length. So by equating these two, on comparing the coefficients components, we get x minus 4 and y minus 3. So in this way we get the coordinates of D are -4 -3. Now students, I am sharing you the next question, question number 11. This is very important question. In this question we have the write the direction ratios of the vector and helps calculate this direction cosines. This is very important question for CBSE. Here direction ratios must be 1, 1, -2. And for that we need to calculate direction cosine. We will write here 1 over under root square of components of ijk. In this way we get here 1 over under root 6. This is very easy question. In the same way we calculate the component of j and k as well. So here we have last question. This is similar question students, you can do yourself. So in this way today we have completed exercise 12.3, and if you like my video then please like, share and subscribe. Thank you for watching the complete video.